This video is on solving by factoring. We're going to be solving quadratic equations by factoring the problems first, and then we're going to solve each equation to find the x-intercepts. So when we're solving, another word for solving is to find the x-intercepts, the roots, the zeros, the solutions. So even if we've already seen before how to find the x-intercepts, we're doing the exact same thing. So solving is just finding the x-intercepts. Now, possible solutions for quadratics. Quadratic is a parabola, and the solutions are when it crosses the x-intercept, or when it crosses the x-axis. So a solution is how many times does it cross the x-axis. So if you have two solutions, our parabola can cross the x-axis twice. Now, these values can be real, or they are real. They can be rational, meaning they can be nice, clean numbers, or they can be really, really bad decimals, like the square root of 3 would give you a bad decimal. That is an irrational solution. But two solutions is when the parabola does cross the x-axis twice. A quadratic can have one solution, and that's when your quadratic bounces off of the x-axis. So your vertex is the same as your x-intercept. That's when you have a perfect square trinomial. But then we can also have two imaginary solutions. Now, an imaginary solution is when the quadratic will not cross the x-axis. So our parabola would be opening up, and the vertex would be above the x-axis, or if the vertex is below the x-axis and opens down. This would be two imaginary solutions. This also tells us that the quadratic is not factorable. If you have one solution where it bounces, the quadratic is factorable, and it will turn into a nice, perfect square trinomial. Two solutions, your quadratic may or may not be factorable. If it is factorable, then your solutions will be clean values, nice whole numbers or integers or fractions, so anything that is rational. It is not factorable if your solutions end up being an irrational number. So to solve by factoring, we're going to factor the quadratic equation, and then we're going to solve using the zero product property. So what the zero product property states that if A and B are expressions, so that could be, again, any type of expression, x plus 5, x plus 2, and the zero product property states that if A and B are expressions and A times B equals 0, so if the equation is equal to 0, and when you're multiplying by something, if one of these values is 0, the entire thing will become 0. So if A is 0, then the entire expression is 0. So if these are equal to 0, then A could be equal to 0. Or the B value, the B expression could have been equal to 0. So if A was 0, and I multiplied 0 times whatever B is, the entire expression will become 0. The entire equation is 0. If B was 0 and I did A times 0, then again, everything would be equal to 0. So if we already know that the equation is equal to 0, then we could take either one of the expressions and set it equal to 0, because one of the expressions, at least one of them, has to be 0. So what that means that if we have the equation x plus 5 times x plus 2 is equal to 0, the first expression, our A expression, is that x plus 5. So that entire x plus 5 could be equal to 0. Or the second expression, that x plus 2, could be equal to 0. But because it has a variable in it, that's why we need to make sure that we set that equal to 0. If the x plus 5 is 0, if this entire expression is 0, then the entire equation will have to become 0. If the x plus 2, that expression is 0, then the entire equation will be 0. And we know that the equation has to be 0, so we want to find the values that could make this equation 0. So again, if the x plus 5 is the 0, well, what plus 5 will give us 0 to make this entire expression 0? If we were to solve using the zero product property, we would subtract the 5, and x would equal to negative 5. So if we had plugged that in, negative 5 plus 5 is 0, and 0 times this entire expression, no matter what it is, will be 0. But we could say the same thing for the x plus 2. If this x plus 2 is 0, everything's going to end up being 0. So what will be added to 2 to make it 0? If we use a zero product property, we're going to solve this so we can figure out what will make this 0. If we subtract the 2, we'll get x equals negative 2. So if we plug it in, negative 2 plus 2 gives us 0. So no matter what, this 0 times whatever is left will end up being 0. So what we do is we take the expressions that have variables in it and we set them equal to 0. And we solve for the variable. This is how we do zero product property. So an example of solve by factoring is we have to factor the quadratic equation, then use the zero product property to solve. So if I wanted to solve this by factoring, so it says solve by factoring, I have to factor this problem first. In order to factor it, it has to be equal to 0. All of the equations, all of the quadratic equations need to be equal to 0. So I need to put this into standard form. So to put this into standard form, I already have a positive 2x squared, then I have the negative 11x, but my negative 15 is on the wrong side. I need to add this to the other side, so we'll end up having 2x squared minus 11x plus the 15 is now equal to 0. Because again, we want to end up using the zero product property to figure out what values of x will give us 0. But we have to factor this. Now the first step in factoring is to find your GCF. Our GCF in this problem, we would look at our smallest number, which is 2. 11 cannot be divided by 2, so we know GCF is not 2. Then we figure out what multiplies to 2, which is 1 and 2. Therefore, our GCF has to be the 1. All three of these terms do not have a letter, so our GCF is just 1. So we do not have to factor out the 1 from it. Now, since there are 3 terms, we're going to use MACAB. Our A value is equal to that positive 2. The B value is equal to negative 11. And the C value is equal to the positive 15. So when we use MACAB, do my half box, the MAC, which is multiply your A and C, I'm going to put that on top. So that's 2 times your 15. 2 times 15 is 30. And then we're going to put our AB, what adds to B, which our B value is negative 11. So inside this half box, I'm going to list out everything that multiplies to 30. So that is 1 and 30, 2 and 15, 3 and 10, 4 does not go into 30, 5 multiplies to 6, and then the next one would be 6, which we've already written. So now we need to notice I did not use any signs on here because I just want to make sure I know what multiplies to 30. Then I'm going to check to see which ones can add to a negative 11. So 1 and 30 will never give us an 11, so I'm going to cross those out. 2 and 15, if I were to do anything with that, it could give me a 13, but not an 11. So those will be gone. 3 and 10 also would give me either a 7 or a 13, which is not an 11. 5 and 6 could give us an 11. So 5 plus 6 is 11, but I need a negative 11. So if I have a negative 5 and a negative 6, that will give me a negative 11. But I have to make sure it max correctly. So negative 5 times negative 6 is a positive 30. Negative 5 minus 6 is negative 11. So this MACABs correctly. Now we need to determine if we need to use the box, the 4 boxes for MACAB. Since our A is equal to 2, we must use the box. If A was equal to 1, we would not have to use that next box. So I'm going to make my box over here because we need to factor this. So in this first box, I'm going to go back to my standard form. My first box, I'm going to put my entire a part, the entire quadratic term, which is that 2x squared. And in my last box, again, I have to go back to my standard form. I put that positive 15. Now the other boxes, I'm going to use my MATLAB from that. I'm going to take my negative 5, put it into this next box, but I have to put it with that letter x because they have to share the letter. My next box, I'm going to put that negative 6 also with that letter because they have to share a letter. Now I factor out the GCF of each row and each column, and I'll have my factors. So for this first row, my first sign is positive, so I know it's going to be a positive. My smallest number is 2. 5 cannot be divided by 2, so my GCF so far is a 1. But these both have a variable of x, and the smallest amount of x's is just that 1x. So I have a GCF of 1x here. For this next row, my first sign is negative, so I'm going to have a negative. My smallest number is 6. 15 cannot be divided by 6, but I know that 2 times 3 gives me 6. So if I look at 3, 15 can be divided by 3, so my GCF for there would be a negative 3. And these both do not have an x. So now I'm going to do my first column. Come up here. My first sign here is positive. My smallest number is 2, so 6 can be divided by 2, so my GCF so far has a 2 in it. These both have an x, and the smallest amount of x's is that first x, or just that one value of x. My next one, my first sign is a negative. My smallest number is 5. 15 can be divided by 5, so we'll have a 5. These do not both have an x, so my negative 5 is the end of that. What we'll do, our GCF was 1. Then I'm going to put my values here into factored form, so this becomes 2x minus 5, close parentheses, times 1x minus 3, close parentheses, equals to 0. Because all we've done is taken the 2x minus 5 and the x minus 3, put it into factored form, because this quadratic turned into here. We haven't changed the way it is, we've just changed the way it looked. So the equation is still the same, it just looks a little different. Because now I can use the zero product property and figure out what value of x will make this entire equation equal to 0. So we take our values. If it has a variable inside the expression, we need to use it. So this first expression is 2x minus 5. It has a variable, so I need to take this entire expression, 2x minus 5, and set it equal to 0. Then my second expression is x minus 3. It also has a variable, so I need to take that expression, x minus 3, and equal that to 0. Because it does not matter if this expression is 0, the entire equation will be 0. If the second expression is 0, then the entire equation will be 0. So when we solve for x, we have two equations we're going to solve. So we're going to add 5 to both sides on this first one. So we'll have 2x is equal to a positive 5. Then we're going to divide by 2 on both sides. So we'll have x is equal to a positive 5 over 2. That's our first solution. And then for our second one, we have x minus 3, so we're going to add 3 to both sides. We'll have x is equal to a positive 3. X is alone, so our answer is x equals positive 3. What that tells us is that we have a quadratic crossing the x-axis twice, one time at 2.5 and another time at positive 3. So our solutions, our x-intercepts, our roots, our zeros are at 5 over 2 and positive 3. So again, this is just showing that our parabola is going to cross the x-axis at these two distinct locations. We factor the problem, and then once we factored it, we set the expression equal to 0 because that is what the zero product property states.